My warm wishes to everyone. Myself, J. Chandana, graduating from Srinivas Ramanujan Institute of Technology, holding a roll number 234Z1A0425, and I am from EC department. Today, my topic in this presentation is joint characteristic functions with example problem from the subject probability and complex variables. The definition of the joint characteristic function is characteristic function of two random variables, that is x and y, is defined as the expected values of the joint function g of x comma y is equals to e power j m1x into e power j m2x. Pi xy of omega 1 comma omega 2 is equals to expectation of e power j m1x into e power j m2x. These e powers are the same, so we will take it as expectation of e power j m1x plus e plus j m2x, where omega 1 and omega 2 are the real values. Pi xy of omega 1 comma omega 2 is equals to double integral of minus infinity to plus infinity e power j m1x plus j m2x into fxy of x comma y into dx dy. Inverse Fourier transform of the joint characteristic function gives the joint density function, that is fxy of x comma y is equals to double integral of minus infinity to infinity pi xy of omega 1 comma omega 2 into e power j omega 1 x plus j omega 2 x into d omega 1 into d omega 2. If x and y are discrete random variables with probability mass function px comma y, then pi xy of omega 1 comma omega 2 is equals to summation m into summation n into e power j omega 1 xn plus j omega 2 into xn into p xm1 into yn, where px xm comma yn is equals to summation m summation n into e power minus j omega 1 into xm minus j omega 2 into yn into pi xy of omega 1 comma omega 2. Now let us see what are the properties of the joint characteristic functions. First one is magical characteristic functions are given by pi x of omega 1 is equals to pi xy of omega 1 comma 0 and pi y of omega 2 is equals to pi xy of 0 comma omega 2. And the second one is if two random variables, that is x and y, are independent, then the joint characteristic function is equal to product of their individual characteristic functions, that is pi xy of omega 1 comma omega 2 is equals to pi x omega 1 into pi y omega 2. Now the third one is if x and y are independent random variables, then pi x plus y of omega is equals to pi x of omega into pi y of omega. And the fourth one is if x and y are two random variables, the joint moments can be derived from the joint characteristic function, that is mnk is equals to minus a power n plus k into dou power n plus k into pi xy of omega 1 comma omega 2 by dou omega 1 power n into omega 2 power k, where omega 1 and omega 2 is equals to 0. Now let us see the problem. The question is the two random variables x and y have joint characteristic functions, that is pi xy of omega 1 comma omega 2 is equals to expectation of minus 2 omega 1 square minus 8 omega 2 square. Now we have to show that x and y are 0 mean random variables, and also we need to prove our x and y are correlated. Now the given characteristic function is pi xy of omega 1 comma omega 2 is equals to expectation of minus 2 omega 1 square minus 8 omega 2 square. From the fourth property, the joint moments of order n plus k are mnk is equals to minus j into dou by dou omega 1 power n into omega 2 power k into pi xy of omega 1 comma omega 2, where omega 1 and omega 2 is equals to 0. Firstly, the first order moments are m10 is equals to expectation of x, that is equals to minus j dou by dou omega 1 into pi xy of omega 1 comma omega 2. So pi xy of omega 1 comma omega 2 are given in the question. So minus j into dou by dou omega 1 into expectation of minus 2 omega 1 square minus 8 omega 2 whole square, where omega 1 and omega 2 are equals to 0. Now we need to differentiate with respect to omega 1. So we'll get minus j into minus omega 1 into expectation of minus 2 omega 1 square minus 8 omega 2 whole square, where omega 1 and omega 2 is equals to 0. Finally, we will get m1. If we substitute omega 1 and omega 2 is equals to 0, so overall term will be 0. So the mean value of x is 0. Now if you calculate m01, that is expectation of y, we need to differentiate with respect to omega 2, that is minus j into dou by dou omega 2 of pi xy of omega 1 comma omega 2, where omega 1 and omega 2 is equals to 0. So if you substitute pi xy of omega 1 comma omega 2, that is expectation of minus 2 omega 1 square minus 8 omega 2 whole square. So if you differentiate with respect to omega 2, you will get minus j into minus 16 omega 2, that is 8 omega 2 whole square. If you differentiate with respect to omega 2, we will get minus 16 omega 2, and the expectation of minus 2 omega 1 square minus 8 omega 2 square, where omega 1 and omega 2 is equals to 0. If you substitute omega 1 and omega 2 is equals to 0, so the overall term becomes 0. That is expectation of y is also 0. So the mean value of y is 0. Second question, what we need to prove is are x and y are correlated. So now let us see how they are related. If you see the formula cxy is equals to rxy, that is equals to expectation of x into expectation of y, that can be written as expectation of xy, that is equals to m11. If you see the formula of n11, that is equals to minus j omega square into dou square by dou omega 1 into dou omega 2 of pi xy of omega 1 comma omega 2, where omega 1 and omega 2 is equals to 0. Here we have minus j whole square, means that is equals to j square. We will write I square is equals to minus 1. So here j square is also equals to minus 1. That will be equals to minus of dou square by dou omega 1 into dou omega 2 of expectation of minus 2 omega 1 square minus 8 omega 2 whole square, where omega 1 and omega 2 is equals to 0. If you differentiate with respect to both omega 1 and omega 2, we will get minus 4 omega 1 into minus 16 omega 2 of expectation of minus 2 omega 1 square minus 8 omega 2 whole square, where omega 1 and omega 2 is equals to 0. If you substitute omega 1 and omega 2 values in this equation, you will get 0. So m11 is equals to 0. If you substitute these m11 in the above equation, you'll get cxy is equals to 0. So x and y are uncorrelated. Thank you for watching this presentation.